Hello, everyone. My name is Daniel Machlab, and I'm honored to be here today at BazelCon. I'm going to tell you about how we're using Bazel at VMware to create a more accurate and efficient open source licensing compliance process to address challenges with our current solution. I've worked closely on this project with Rihanna Tabassum, Mark Zarian, and several others at VMware. We hope this talk and our work will inform the design of general purpose licensing infrastructure for the Bazel community. With hundreds of thousands of open source projects to choose from for a developer, open source software is a vital component of almost any code base, sometimes making up more than half of a code base. And with over 80 licenses, each requiring its own unique care, complexity of managing open source software cannot be overlooked. At VMware, like many other organizations, product releases must comply with legal and license requirements of open source software. For us, this process adds friction to the development cycle, sometimes results in product release delays, and has occasional inaccuracies. To solve this problem, we've created a new open source compliance process rooted in Bazel. I'll first give you a little bit of background about open source license compliance. Then I'll expand on our current workflow and its shortcomings, and finally, I'll tell you about our solution. In order to comply with the licenses for the open source software that VMware uses in its codebase, we must first identify all the open source packages that we're using. This is like having a haystack full of needles and needing to find all of them, or face legal and security risks. Second, all the open source must be tracked, so legal and security teams can approve or deny the packages. If a package is found not to be fit for use at VMware, the package must be removed and the code must be refactored. And finally, we must be compliant with the licenses of the software we use in our products by providing the proper documentation upon product release, where documentation requirements vary by license and by package. The ideal scenario is to have a process for identification and tracking of open source software in order to reach license compliance with the least amount of toil, inaccuracies, and product release delays. The way in which open source compliance is accomplished varies by organization. Let's take a current look at the workflow that we use at VMware. In the current workflow, there are two strategies for a developer to gain approval for open source package usage. The first option is for them to run a local build, use a CLI tool to scan for open source software, and use another CLI tool to file tickets to track the open source software. In the second option, a team can set up its own continuous integration pipelines, where after developers check in code, new builds are triggered. The latest build artifacts are scanned for open source software, and tickets are created for any newly added packages. After tickets are filed to the OSS review tool, people from the legal and security team review the packages asynchronously. If any package is found denied for use, developers are notified and the package must be removed. And there are some pain points with this workflow. First are the manual steps that are required. This leaves room for human error, such as when having to run local builds or using multiple CLI tools to identify packages and track them. Second is that each team has to set up and maintain their own scanning pipeline. Different products have different configurations to account for different package managers. And because of this, there's no standard process for all teams to follow. The manual process for each team to set up their own scanning pipeline is another source of human error. For example, we encountered a team that was scanning the unit tests instead of the deliverables for their product. This resulted in packages being reported that weren't actually shipped. Conversely, there are scenarios where packages are underreported. In those cases, packages are potentially shipped without first being reviewed or declared. The third pain point is that scanners sometimes don't produce all the required information we need to know about an open source package, leaving some information missing. The first example of this is that scanners can't always determine whether a package is shipped or if it's for internal use only, like for testing. This overreporting adds cost to identifying and tracking tickets. In fact, these internal packages made up 20% of the tickets filed, incurring a huge amount of wasted manual labor from developers to rule out these false positives. In this second example of this missing information, scanners cannot always identify how a package is used, such as if it's dynamic or is statically linked. Filling in missing information like this is a manual process, leaving room for error. For example, during one of the first releases of a product with Bazel build binaries, the linkage was mistakenly changed from dynamic to static. This slipped under the radar until it was caught in the last second before product release, causing a headache to correct the error that should have been avoided. The fourth pain point is the toil in the feedback loop when developers add denied packages to the code base. An open source package could be denied for legal or security reasons, and a developer will have to remove the package and refactor the code. To handle this, we have a Slack channel integrated with a scanning tool that tags product owners with open source packages needing removal. The owners have to identify the developer that introduced the package and delegate the task to remove it accordingly, which requires Slack messages, emails, and sometimes even bug tickets. This can be especially inconvenient when a developer adds a package to the code base that was already denied, and they don't receive feedback that they need to remove it until days or even weeks later. Because of this, developers cannot easily make informed decisions about implementing or choosing open source packages. To address these pain points, we set out to design a new solution. Our goals were to minimize toil and product release delays, improve the accuracy of open source packages we identify in products, and support multiple programming languages so any team at VMware using Bazel can use our solution. And we did just that. By using Bazel as the foundation for our open source license compliance process, we experienced many benefits. First, we can create an accurate, deterministic bill of materials containing all open source with each build. There is no need for a separate open source scanning step in the post-build stage. This removes toil and room for errors from developers. Second, open source validation happens at build time, and developers are quickly informed about any problems with the open source software they've introduced or the existence of any denied packages in the code base. Open source decisions are made earlier on in the development and review process, making them less costly. Additionally, common causes for product delays are mitigated. And the third benefit, Bazel's multi-language support allows us to have one tool that works cross-platform. This removes scanning pipeline setup and maintenance from a team's responsibilities. Now let's walk through how this works. We start with a Bazel build that just produces an RPM package with the project's source files using package RPM as seen here. Previously, there would have been a post-build step to scan the RPM that we produce. But now, with our new solution, all that we need to do is add a new rule called OSS audit into the Bazel build. The OSS audit rule consumes a Bazel aspect that analyzes the dependency graph of a build and collects information about each package. Additionally, it consumes a list of previously approved and denied open source packages, usually determined by a legal or security team, to alert developers when denied packages are being used. After the aspect traverses all the dependencies, OSS audit outputs two files. First, it creates a BOM YAML file, which includes information on each open source package. And second, it creates a BOM issues file containing a subset of open source packages that have been denied for use by the legal or security teams or that are still waiting for approval. Developers and release managers can use the BOM issues file to identify problems or packages that may block or delay a product release. This is the workflow for using OSS audit. Now let's check it out, how it works in action. This is how OSS audit can be added to a build file to audit an RPM. In this example code, you can see package RPM rule below, creating the RPM, and the OSS audit rule above, auditing the RPM. The solution can audit RPMs, TARs, and other build targets, but it's currently only aware of Java dependencies via metadata from rules JVM external. Don't worry, it can be extended to support other target types as well. We're currently developing a prototype that supports C++ and have plans to support other languages soon. The approved and denied lists inform OSS Audit about which packages are approved and denied, and provide extra metadata as well to be included in the bill of materials, such as copyright notice and how a package is used. All open source packages will show up in the BOM file, but a subset of the BOM containing only denied and pending packages will show up in the BOM issues file. Now, let me show you a demo where I'll apply OSS Audit to a simple example project. The project that we'll be auditing is an example project from the Bazel build repository on GitHub. It's a Java application that compares two numbers using the instaCompare method from Guava. Guava is an open source project, and looking at the workspace file, we can see that it's being imported here using maven install from rules.jvm external. Checking out the build file, we can find a Java binary that, when built, produces a jar for our project. Here's the jar, and we could go ahead and directly audit this Java binary using OSS Audit. But to make things more interesting, we're going to make an RPM that packages the jar and then audit the RPM. Here's the code that we need for the RPM. Now we're ready to bring in OSS Audit to audit this RPM. And here's the OSS Audit code. The source is the RPM that we're auditing. And then here are the approved and denied lists. The approved list has one entry. The key is the package identifier for Guava, and the values are information from the OSS review tool. The denied list is empty, and we're ready to go ahead and audit this RPM. The audit gives us a BOM and a BOM issues file. Let's first check out the BOM file, which contains all the open source packages discovered during the build. Looking at the BOM, there are several entries. The key is the package identifier, and the value is information discovered about the package during the audit. If you remember, we were only depending directly on Guava, so the rest of these packages are transitive dependencies. Looking here, you'll see the copyright notice for Guava. This is an example of how information from the approved list makes its way into the BOM. Now, let's check out the BOM issues file. The BOM issues file contains all the packages that are waiting for approval or denial from legal and security teams. These are all the transitive dependencies of Guava. What happens when we add a package to the denied list? Let's add findbugs JSR 305, one of the transitive dependencies for Guava, into the denied list. Now, to be clear, there's nothing against findbugs, and I'm only adding it into this denied list for demonstration purposes. All right, let's go ahead and run the audit once more. This time when we run the audit, the build fails, and we have an alert message letting us know that findbugs JSR 305 is denied and needs to be removed from the code. Now, it might not always be a convenient time to remove JSR 305 from the code, so what we can do is we can use a suppress list. This is an attribute of OSS Audit, where any packages listed in this list that are denied will not fail the build. It is a good idea to have a bug number here to track the removal of these packages, since ultimately they still are denied. We can go ahead and run this build one more time, and we'll see that the audit this time succeeds. We have our BOM file, our BOM issues file, and we're still reminded by the build that there are some packages that need removal. And that's an example of how to apply OSS Audit to a project. Now, let me show you how the use of OSS Audit can be extended beyond just open source identification. Let me show you a few examples of how we use OSS Audit at VMware. The OSS Audit outputs can be inputs to other processes to gain legal or security approval. At VMware, a Jenkins server uses the BOM to file tickets for open source packages for review. people at the legal and security teams review the packages asynchronously. This Jenkins server also queries the OSS review tool for the latest approved and denied packages, and it creates a new approved and denied list to submit back into source control. Now, if any packages are denied for use, developers are notified the next time a build runs. Now, this is how we've integrated OSS Audit with our existing OSS review tool. To wrap up, let's check out one more example about how we use OSS Audit in our big products. At VMware, our bigger products are constructed of many services. In this case, OSS Audit is used to generate a BOM for each service. These service BOMs are then merged together to create one top-level BOM and BOM issues file for the entire product. This gives product and service teams insight into what packages they're shipping at varying degrees of granularity. I've shown you the problems with our current workflow. I've shown you our solution and a couple ways of our solution can be extended. In summary, open source software is a critical piece of almost any code base, but complexities of identifying and tracking it slow down the product development cycle and can result in product release delays. Using Bazel as our foundation, we're able to validate open source usage at build time and produce a BOM containing all open source software in the code base. This gives developers immediate feedback, removes tedious extra steps, and provides a single cross-platform product-agnostic tool. We're interested in engaging the Bazel community to see what kind of open source compliance solution would work for the ecosystem. We're looking for feedback on this solution to help it evolve. Our call to action is to visit our GitHub, check out the code, or even open an issue to continue this discussion. Thank you very much for tuning in.